Up some music. Cheer now to be number one. Desktop's all nice and clean. Scorpbot is running. Streamlabs is running. Let's get this going. Let's get it on. Remembered my USB cable today. Good. Ooh, I have crazy notifications going on here. What is happening? Awesome. Okay. And Unity is thinking about entering... Oh, hey, you know what I was going to do? I don't think I have my Scorpbot window for followers set up in my video. Oh, maybe that is it. Widget type, alert box, shippity-dibbity-doo. Oh, I have the default one, so I don't really need that thing. I do need to update all of my follower notifications, that sort of stuff. Not that it's a huge deal. It's not like I'm swarmed with followers every day. I don't have to worry about that stuff that much. Alright, oh, and I should open my speech chat so I can hear people. Very interesting. Okay. There, I have like 1 million chats open. We're good. All right. Previously on 1 Hour AR Game. Okay, so I've got this matchbox, which is a box that matches things. It isn't a box of matches. Let's do a quick animation for the lid. So we're actually just I'm just going to create a Matchbox controller. So we want a C# script, and we're just going to call it box controller. We'll give that a second to instantiate, and then we'll open it in Visual Studio. Yum. And while I'm doing that, I'll hook up my phone so I can test. Nope, mixed reality portal, I don't need you. I do not need you, I do not need you. Why are you popping up? Pop, pop. That was embarrassing. Alright. Previously. Switch my headphones here. There. I'm going to slide the game window back in here as well, so that when I do get around to launching it, you can see it. All right. Soup. Yum, 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 yum. Okay. So one thing I wanted to do is in the box, I wanted to make it so that I can control the position of the animals a little bit. Actually, that would be on the... I know where it is. All right. Okay, so the plan. What is the plan here? Okay, we're going to fix those line endings. We've got the Matchbox controller here. I wanted to add into the... so you can see we've got a Matchbox, should have a box, an animal type, and we should also have a public vector3, and we'll call this animal offset. We'll call it animal position offset. There we go. So just to kind of sum up where I'm already at, I have this Matchbox here. Now it's for matching things, so you're going to look at the game through augmented reality, and you're going to like open two boxes, and you're going to see what's inside, and if they match, they'll stay open, and you'll get like, you know, coins or something, and if they don't, then you'll go back to trying again. Ideally, I want it to be multiplayer. So my initial concept for multiplayer is that we'll detect the position of the phone, and when the phone is passed, it'll move on to the next player. So we'll see how that goes. And then we can use the central location and the angle around the central location to determine which player it is. So if you're all sitting at a table, I want to create a foundation for games that are designed to be passed, like to have your phone passed around, because that's totally safe for phones to be passing them around at a dinner table. Anyway, yeah. So if I go into, let's get rid of our example. We've got plane generator, point, cloud, environmental light, directional light, canvas, event system. Here's my Matchbox controller. So we've got box types here. So I've got a default animal scale there. Yeah, I think that needs to be here. So if I put that in there, then it should add a vector3 to each of these. And then that way I can tweak the position of each animal as I need it. So right now I've got it spawning all 8 different animal types when I hit play. So if you have a look here, oh, okay, let's do that. Okay, so right now you can see we've got our boxes here. I'm going to hide the lids. There we go. Now we'll clear that out so we can see what animals are inside. So you can see the bunny's in a good position. The cow is too far forward, right? So I'm just going to click on a cow right now, and we're going to slide it back this way a little bit. That's not the cow, is it? So that Z value, that's what I need right there. So now you'll see in my setup, under cow, if I can find my cow, if I apply that Z there, then what I want to do is when I'm instantiating my cow, then I want my MB animal dot transform dot translate, and that's going to be box types x dot animal position offset. So basically what that's going to do is now when we spawn the animal, it should apply that slight adjustment that I just put in there. And in theory, if I'm not wrong, and I am never wrong, so now you can see it's actually previewing through my phone, so, and you can see the boxes are there. But it says searching for surfaces. Let's see if we can get it to find a surface. I found my finger. Oh, there we go. I found the surface. So that much is working. Okay, good. Okay, so in the scene, if I get rid of the lids, then my cow now should be more centered. Yep, good, and he is. So that's good. Let's see who else needs to be offset. So the dog as well. Let's just see him. Can he have the same one? A little bit. There we go. So the dogs should be that. Who else? The sheep seems good. The pig may actually be a little bit too big. Yep, the pig's too big. We got a bigger piggy. Alright, so. And the cat. So the dog and the cat can probably have the same value. Yep. Okay, so we'll handle the piggy in a second. So we're going to go into our Matchbox controller. We're going to find the cat. We're going to apply this. And we're going to find the dog. And we're going to apply the same thing. Now, we're also going to add a public vector 3 animal scale override. And so if our box type x dot animal scale override is not equal to a new vector 3, then we'll do the override, else we'll use the default one. So all that's going to do is make sure that that animal can be scaled slightly differently if needed. Good. Okay, so what we're going to do now is on the pig, we're going to reduce his scale a little bit. So currently the pig is 0.6.6.55. So we're going to actually bring that down to 0.5, 0.5, 0.47 maybe. Let's see how that works out. Okay, so if we hide our lids, cat's in the right place. Pig seems much better scale, but he's still in the wall. So let's see if we can fix that with a little bit of positioning. See if he's touching here. He's good on that side. He's good on that side, so he needs to be moved by this much, which just means we go back into our controller, and for the pig we will set his Z position here. Alright, so I think all of the box types are configured, all of my animals are working. My coffee is acceptably delicious. Alright, let's go into the scene. Lids. Hide my lids. We'll flip the lids. There we go. Check the pig out. Pig's good. Everyone looks like they're in their boxes in a good spot. Yeah, I am satisfied with that. Awesome. Okay, so now one of the things that we need to do is that the Matchbox controller okay. Okay, so what we're going to do is we are going to now add in the ability to place that to place the center point of those boxes in the world. So how are we going to do that? So first of all, we are generating. So we're going to take this whole 4 section and we're going to extract this. Oops, hit the wrong button. Stop! Stop! No, just stop. Okay, there we go. Let me make sure. Yeah, so. There we go, extract method, that's what I want to do. And we're going to call this spawn matchboxes. Good. Now, we don't actually want to do that at the start. So now we need a game state. So we're going to create an enumerator here. And our game state will be we'll have start, placed, and then maybe just an end. We only really need 3 game states. And I'm going to make so I'm going to make a game state public variable so that I can toggle that on the fly, and then we're going to handle touches differently based on game state. So in the case of game state, whoops, dot start, we'll handle it one way. So let's look at the Hello AR controller, and you can see here okay. All right. Plane with polygon, feature point with surface normal. Okay, so I have an idea. When we first generate, no, let's handle what we're handling first. So we actually need all of this. So let me see where that starts. If we got a trackable hit, good. So oh, I don't need to, I just need to copy that. All right, so we're going to copy that in, and then we're going to just extract that method. And what are we going to call that one? We're going to call this one handle box placement. Okay. So we've got this Andy prefab. We don't need that. Okay, so we don't really need any of that. I'm going to comment it out for now because I may need some of this code in here. But for our code, we're going to okay, so we're going to create a new game object. So we're just going to go game object box holder equals new game object. I'm going to actually pull that up here. Because I may need to test for the existence of that later. So, and then box holder dot transform dot position equals hit dot pose dot position. And our box holder transform rotation, so we're going to put our rotation in there, equals our hit pose rotation. Good. And let's get rid of this game object declaration so that it uses the existing one. And then we want to spawn our match boxes. But we're going to put in a game object here called parent. Parent object. And then so we're going to go our mb.box.transform. Local position equals a new vector 3. That's just going to zero it out. But first we're going to do mbbox.transform.parent equals parent object dot transform. So that's going to make sure that it's nested underneath the parent object, so that if we move the parent object, it'll work. All right, so good. All right, so so let's spawn those matchboxes and see what happens with the box holder. And then the other thing we need to do is we want to make sure that our game state is changed to placed. That way we know we don't need to replace it again. So let's have a look and see what happens here. Press play in Unity Editor to stream. Let's see if this works. It's thinking about it. Searching for surfaces. Oh, that's weird. It started at a really weird offset. Okay, that's better. Weird. The camera texture resolution is 1088 by 1020. Interesting. Okay, so it's not detecting my taps. So what we're going to do is we're just going to go in and see what happens when I tap right now. So we're going to attach this to Unity. Okay. All right, that actually seems to have worked. That's interesting. Hey, look, it placed my boxes in the world. Cool, and then if I tap again, it shouldn't do anything. Okay, so the boxes need to be smaller if we're playing at table scale, but it's a start. So I'm going to take the game window and we're going to pop it out here so that we can scale it to, what did it say, 1088 by 20? So 1088 by 2080. So 1088 by 2080. Okay. There. So now when I hit preview, we should get a little pop-up here of the game as it's supposed to be, not as that weird scaled thing. So that means I can put my scene preview back to here. Okay, so our matchboxes are too damn big. So if I half the size on them, let's see how that works. We're going to apply that to the prefab, and let's test it again. There they go. Okay. So they need to be smaller and less spaced. But that's a start. And we're going to do like 544 by 1040. There we go. And then that way we can get a nicer preview that runs that's a little bit more performant in preview. There we go. So we've got a surface there, tap on it, boxes appear. Again, boxes are really weirdly spaced, but oh, I see. It's detecting red as walls and white as floors. Interesting. Good to know. Okay. So we're going to have a quick look at the plane generator, detect a plane visualizer. Let's see if we can tell it not to do vertical. Oh, sorry. I just had an idea. So, one thing I'm going to have to do is have cheat detection. So watch. I scan the environment. We get a surface. I place my boxes on that surface. And then if I move inside it, I can see what's in there. I can see who's waiting. So we're going to need to make it so that when someone gets too close to a box, the whole box hides itself. Creepy inside of cat skull. Anyway. So that's a good thing to know about now as opposed to later. All right. Funny. Hey, DJ Yates, how's it going? All right, so not sure if you joined in time, but I actually just discovered that my game is easy to hack. Like a 2-year-old could figure out a way to cheat at my game. All right. So, for the boxes, oh, I can stop this now. All right, so we've got the box placement is working. We spawn the match boxes, and in here we're going to take the. So we've got this spacing based on the X value, but. I actually want to create an int of row equals 0 and int col equals 0, and then we're going to have an int just b equals 0. So b is just going to be which box we're on. So every single one of these, at the end of it, we're going to increment b. Oops. There we go. And then so now I just need to do a quick bit of positional thinking, which my brain is not in the mood for, but I'm going to do it anyway. I think I'm going to do it on a piece of paper. So basically the idea is I'm building boxes. I've got, right now I'm setting them up in 2 rows, but if, whoops. So, but 2 rows won't work. I want them in a grid. So if I have 2 matches, it should be a 2 by 2 grid. If I have 4 matches, will it just be a 4 by 4 grid? No, it won't. So if I have 4 matches, that means I have 8. So that should be like oh, why is my brain not working here? So 16 would be a 4 by 4 grid. Let's just say if b is greater than our number of matches. So no, that won't work, because it's once it hits a point, it's always going to be, why is my brain not working today? I'm just trying to make a 4 by 4 grid. It seems like that should be the easiest thing in the universe. Not if, well, I mean, for a 4 by 4 it's fine, but for a number that I can adjust, because I may want to start with like a 2 by 2 grid, and we can't do a 3 by 3 grid because that's 9, and then you won't have an even number of matches. Okay. What else can I do about that? So if I have 3 matches, that means I have 6 things, which means I should have, well, 2 rows of 3, basically. You know what? Let's just do it this way. So row equals okay, so let's pop open a little bit of calculator here. So if we have 3 matches, that means we have 6 objects. When we get our 4th object, modulated by 3, which is our number of matches, we should have a 1. Okay, so 0. So if our modulus is 3, which is our number of matches for a 6, 0 will be 0, so that'll be column 0. Column 1. Column 2. So it'll go 0, 1, 2, and then when we go to 3, it'll go to the next one. Okay, that works. So at the end, so what we want is we want our B times number of matches, and we actually want that to be our column. Okay, so this will work. So we want column here, and we want row here. And let's drop these to like 0.1 just to put them in a little bit. We'll put 1.5. That'll tighten them up a little bit. Good. All right. Okay, I feel like this is going to work. So now the other thing is now that we're iterating the column, we need to also if B times our number of matches equals 0, which it shouldn't be after the first one, then we want to up our row. Cool. Okay, I think that'll work. So, on our Matchbox controller, if I say our number of matches is 2, we should get a 2x2 grid. So let's test that out. Oops. Give me a surface, baby. Give me a surface. There we go. Okay, so if I tap it, good, a 2x2 grid. Perfect. Okay, so that works. Now, if I go up to 3, I should get 2 rows of 3. Good. So far, so good. Now 4 matches should be 1, 2, 3, 4. Four will be weird. Let's test it out. I think it'll just be 2 rows of 4. Okay. Not bad. I may have just recreated the same thing that I already built. This is not optimizing this at all. Why am I so dumb today? So with 10 objects, well, I mean, it might be that there's... Let's see what happens if we go up to 8 matches. Yeah, it's just doing 2 rows. It's doing the exact same thing it did before. Oh. So if... So we want, let's just go for an int that is so let's call it match row. Okay, so match row length, or match, we'll call it match column len equals the square root of the number of matches. And then we need to cast that as an int. Okay, so and we probably want to add one to this. All right, Bizarro World, let's see if that works. Almost. Okay, so let's just see here. So the square root of 8 is 2.8, plus 1 is 3.8. So we want to round up too. Hey, how's it going? Mr. TNDPK? Or Marat DPK? Okay. Anyway, so yeah, what I want is I want to so our number of matches is 8. I don't think the square... Well, yeah. No. Oh my god. That should work. So that's what I have been looking for. Is so the number of matches times 2 should be our column length. So basically... oh, so dumb. I'm so dumb. Okay. That's all I needed to do. So if your number of matches is... if your number of matches is 2, if you double it, that's 4. The square root, again, is 2. That gives you a 2 by 2 column. If your number of matches is 3, then you're looking for the square root of the double. So in this case, I've got 8. So tapping here should give me a 4 by 4 grid perfectly. Oh, whose tail is poking out over there? Or nose, or what is that? Somebody's not correctly positioned in their box. Anyway, okay, so that's good. So now, if I have 3 matches, that means I should have 6 boxes. So I should either get 2 rows of 3 or 3 rows of 2. There we go. Perfect. Now with 4, we've got 8. So we'll probably get 2 rows of 3 and a row of 2. Which is exactly what I'm looking for. Keep it nice and condensed. Oh no. 2 rows of 4. Or 4 rows of 2. Interesting. Now... 5 matches should be 10. Oh, I think I know what I did wrong here too. There's a second calculation that's... There we go. Yeah, 3 rows of 3, that's 9 plus 1 on the outside, which is fine. I mean, I'd never use 5 matches. 6 matches should be 12 objects. There we go. 3 rows of 4, or 4 rows of 3, however it wants to call it. Good. All right, so that's a much better algorithm for the placement of my game boxes. Let's see who was peeking out there. Oops. And in order to do that, we need to bump it up to the maximum, which is 8. Yoink. All right, come on, come on, come on. Oh, thank you. So yeah, it's just a simple matching game. I just wanted to make something easy to test out ARKit and ARCore because ARCore allows you to... Whoa! That crashed my phone completely. Holy moly. Okay. We'll give my phone a chance to reboot here. So yeah, the idea here is that I wanted to make a really simple thing to test out because ARCore, the ability to place things in the real world on Android phones, now supports being ported to iPhone as well. So, in theory, I should be able to create and maintain one code base to deploy to both platforms. So I want to create a little, like, just a kid's kind of like match game and see how that works. Where's my game window? There it is. Okay. All right, good. One more time, but this time with feeling. So we're going to go back to our Matchbox controller. We're going to bump the number of matches up to 8. That should give us a 4x4 grid, and we'll find out who out of my animals is hiding, or is not hiding well enough. So we're going to search for surfaces. Oh, I'll slide this over so you can see. You can actually see my camera. That's my phone in real space, so that's how I know where the person is. So I'm going to scan the environment here. There we go. We're starting to get an idea. I'm going to put it there. And then you'll see over here, I'm going to pause. So if we look down, we can see that one of the animal's tails are peeking out. So let's hide our lids and see who that is. Cow. Cow. All right, so that's cow there. Why is he at negative 0.046? That's interesting. That's very interesting too. All right, so is anyone else sticking out of their box before I fix this problem? It looks like just cow. So okay, so cow is definitely a problem. So we're going to look at the Matchbox controller and we're going to look at our box types. And I set up the cow down here. His position is supposed to be negative 0.023. So if I look at my controller, okay, so I'm going to see if it's just because he was maybe accidentally translating based on world space instead of local space. The other thing we can do is we could probably just add them together and see how that works, but let's just test our cow out here and see if that... No, he's still in the wrong place. You can clearly see his tail is peeking out over there. Oh, good. Well, it's Hey, thanks for the follow. You know where your towel's at. All right, so come on, you. Okay, so I'm gonna hide this lid. So he's moving weirdly, like he's moving double what he needs to. I think I'm applying the transform twice somehow. No, it's only occurring twice within the space. That's so weird. It's so weird. Because he is clearly at 0046. When I have told it to be at Here we go. Negative 0 is 0.23. And he's at 0.46. So it's doubling somehow. It's doubling. What's this at? The animal spawner's at 0 here. So why is it... I wonder if it's because of the scale. If somehow it's getting scaled. Let's see if we apply this stuff before we do any of the scaling. If that affects... Because he is about half scale, which means that the movement could be doubled? Theoretically? It's weird. Nope, still happening. You can clearly see his tail sticking out over there. Okay, here's a theory. What happens if we have the amount that we're moving him? So if we went like 1-1, for example, okay, we've got a surface to play on, tap on it, there we go. Alright, well that worked. It's still doubling, I think, but at least it's doubling to where I want it to. Moo. Yeah, that's better. Hey, Mike.
Hello, Alexander.
All right, so good. We'll call that okay for now. Yeah, I simultaneously stream to both, so I'm actually streaming to YouTube as well at the same time. Oh, and hello, Valmir. I just saw you on YouTube. For some reason, my YouTube chat isn't working. My voice chat. Weird. All right, so good. All right. So now that we're...
Hi, buddy. Good morning. Good morning.
Good morning. Good. So now we need to do a case of game state dot placed. And we're going to create a method in there to handle what happens if you tap on the box. And In this case, we want to do a physics raycast. We don't want the... Okay, let me just... Actually, we don't even need to... I don't think we need that touch, except for the screen position where it was. Huh. How do we do that again? Oh, camera screen point to ray. That's it. And then we want a there we go, collision. Let's just have a quick look at raycast. I should know this, but apparently I don't. Come on, you.
Nina? Dizzy? Good? You?
Oh, it's a raycast hit that we want. There we go. That's all. Let's just call it hit. Alright, so we're going to create a new tag, and then we're going to send it a message that says open up. Okay. And then we want to create, we already created a script to go on this guy
Morning sickness.
called box controller.
You got morning sickness. What?
No, you guys do. I don't know. I realize I'm
Oh, I gotta run. We have a meeting. All right, so I'll see you guys all later. I'm gonna pause this or stop it for now.
It's just so that you got